This is lesson 9.2. This problem is number 12 from page 472, and we're going to be using the traditional method of hypothesis testing. A survey of 1,000 students nationwide showed a mean ACT score of 20.4. A survey of 500 Ohio scores showed a mean of 20.8. If the standard deviation in each case is 3, can we conclude that Ohio is below the national average? We're going to use alpha equal 0.05. First thing we need to do is decide which group we're going to call group 1, which one's going to be group 2. Generally, the first one mentioned in the problem is group 1, but there's no reason that we would have to do it that way. In this case, since the nationwide students are mentioned first, I'm going to call students nationwide group 1, and I'm going to use subscripted variables with a 1 as a subscript on those variables. Our second group is a group from Ohio, of Ohio students. I'm going to call that group 2, which means we're going to use a 2 as a subscript and the subscripted variables representing the Ohio students. So, first thing we're going to do is look at our null and alternative hypothesis. I'm going to write mu sub 1, which represents the mean of all students, of all student ACT scores nationwide, and mu sub 2, which represents the mean of Ohio ACT scores, all students in Ohio. In this case, we are hypothesizing right here that Ohio is below the national average. So if Ohio is below the national average, we're going to actually say that that would mean that the students nationwide would be above Ohio. Okay, so we're going to start off by saying on this one that if Ohio is below, Ohio is the second group, that our symbol would point this direction. Remember, the pointy end points towards the smaller number, and the open end towards the bigger number. So this is really saying that Ohio is below nationwide, or nationwide students are above Ohio, in other words. So this is our claim, showing that Ohio is below students nationwide. So our alternative hypothesis would use the opposite symbol, less than or equal to. Next step would be to go to finding our critical values. So our critical values, if alpha is 0.05, we would look at this symbol. Notice that it's right tail. So alpha is this right tail right here, which makes this area right here 0.45. Remember, you do 0.5 minus 0.05 to get this number, 0.4500. Then we go to our z-chart, and we would look for 0.45 out in the middle of our z-chart, 0.4500. We'd look left, we'd look up. That would give us our z-score, which in this case comes out to 1.65. 1.6 here, 0.05 here. So this z-score, this critical value right there, is 1.65. So if we get a test value to the right of 1.65, we'll reject our null. If we get a test value to the left of 1.65, we won't reject our null. Step C is we're going to look for our test value. Our test value, again, will be a z-score in this case. Our sample sizes are above 30. We're dealing with means. Our first sample mean, x bar sub 1, was 21.4. Our second sample mean, 20.8. Mu sub 1 and mu sub 2, we always assume the null is true. So if we always assume the null is true, then the null also always uses an equal bar. So since those are equal, when we subtract them, mu 1 equal mu 2, when we subtract them down here, that's always going to equal 0. So mu 1 minus mu 2 would equal 0 because we're assuming they're equal. And the denominator, our sigma sub 1 squared, that would be the population standard deviation of group 1 squared. Well, we don't know the population standard deviation, but because our sample size is greater than or equal to 30, we can use our sample standard deviation of 3 right here. So we're going to go 3 squared over our first sample size, which is 1,000 students, plus sigma sub 2 squared. That would be our second population standard deviation. So this would be the standard deviation of the Ohio students squared. Well, again, we don't know the population standard deviation, but we can use the sample standard deviation of 3. So we're going to go 3 squared over our second sample size, which is 500. Type that in the calculator. Take 21.4 minus 20.8, which would be 0.6, then divide by this quantity, our z-score, our test value, comes out to 3.65. Meaning that 21.4 is 3.65 standard errors higher than 20.8. So is that a statistically significant difference? Well, we look up here for 3.65. 3.65 would be to the right of 1.65. It would be in the rejection region. So step D would definitely be to reject the null, because our test value is in the rejection region. So I say reject null hypothesis. So I'm rejecting the null. If I'm rejecting the null, I'm thinking it's incorrect, it's wrong, it's false. So that means I would support my claim down below on the other line. So I'm going to say there is enough evidence to support the claim that Ohio students score lower than the national average. Score lower on the ACT than the national average. And I want to point out that we didn't prove anything. When you do hypothesis testing, you're not really proving anything, but we're saying there is enough evidence, though, to support that claim. Now keep in mind our alpha was 0.05, meaning that there's a 5% chance of type 1 error. What that means is that even if the null is true, there's still a 5% chance of rejecting that null.